Have you ever been stuck trying to find square root of numbers like 7, 33, 197 or numbers that are not perfect squares? You might have had to reach for a calculator to find those, but what if I tell you there's a simple mathematics method to find their square roots quite accurately? In this video, I'm going to show you how to approximately find square root of any imperfect square. So let's begin. First of all, we know the perfect square roots, which are those numbers whose square roots are whole numbers. You might have already memorized many of them. For example, root 4 is 2, root 9 is 3, root 16 is 4 and square root of 25 is 5. But what about numbers like 8, 40, 185 and 1050? These are non-perfect squares, that is, they lie between two perfect squares. So let me show you a logical method to handle these numbers. The idea is very simple. Let's find the square root of 8. I am starting with small numbers first on purpose. Once the method is clear, bigger numbers become very easy. So first, consider the nearest perfect squares to 8, which are going to be 4, whose square root is 2, and 9, whose square root is 3. So as 8 lies between 4 and 9, its square root must also lie between 2 and 3. This we can say for sure. We take the difference between the two perfect squares, which in this case is going to be 5. We have drawn 4 and 9 on a number line to imagine this better. We divide this line into 5 parts, which is the difference between the nearest perfect squares. By doing this, we get 4 points in between. We do the same for the distance between the numbers 2 and 3, that is divided into 5 equal parts. For this, we take another number line. Let's call it the square root number line, which marks 2 and 3 and the distance between them. The next point after 4 is just going to be 5, because the difference is 5 and we have divided it into 5 parts. So each point corresponds to a difference of 1. As we went 1 point ahead on our number line, we will travel 1 point ahead on the square root number line as well. To find the value that we traveled here, we take the difference between 2 and 3 and divide it by 5. So that means we are traveling 1/5 the distance. So we add 1/5 to 2. 1/5 is just 0.2. So that's going to be 2 plus 0.2, which equals 2.2. So that's going to be our square root of 5, which is 2.2. If you check on your calculator, then root 5 is 2.23 up to 2 digits. Our answer is very, very close. Similarly, we can find square root of 6 by now going one more part further on the number line. In that case, we would have covered 1/5 distance twice. So now we add 1 by 5 to 2 twice to get 2 plus 2 by 5ths. That is 2 plus 0.4, which gives us 2.4, which is again very close to the actual value of 2.44. To reach there, we'd have to cover 4 steps of 1 by 5 distance each. So to get root 8, we need to add 4 by 5 to 2, which gives us the answer 2.8. Again, very close to the original value 2.82. Here, you can notice that in case of 5, 6 and 8, perfect squares remain the same, as all the 3 numbers lie between the same perfect squares. Only their distance from the lower square changed. Same logic can be applied to larger numbers. So now let's try root 40. The nearest perfect squares are going to be 36, whose root is 6, and 49, whose root is 7. So again, root 40 will lie between 6 and 7, just as 40 lies between 36 and 49. As in last example, we take the difference between the perfect squares, that's 49 minus 36, which equals 13, and then we divide the distance between 6 and 7 into 13 parts. So if we would want to find square root of 37, we would just travel one part ahead of 6, and by doing so, we would cover the 1/13th distance from 6. So 6 plus 1 by 13 will give us the square root of 37. Cross multiplication will give us 78 plus 1 by 13, which is 79 by 13. And the division gives us the result 6.07. To get to 40, we would have to travel 4 numbers from the lower square 36. So to get to 40, we travel the 1/13th distance 4 times as well. So 6 plus 4 by 13 will give us root 40. The calculation is again same, cross multiply 13 by 6 and add to 4 to get 83 divided by 13, which yields the answer 6.30. The actual value being 6.32. We are very close without a calculator. Let's take a more bigger example, under root 185. Nearest perfect squares are 169 and 196. Their difference is 27 and their square roots are 13 and 14. As 185 lies between 169 and 196, in the same way, root 185 also will belong to the interval 13, 14. To get to 185, we need to add 16 to the lower perfect square 169. So again, to get root 185, we add 16 over 27 to the lower square root 13. The calculation which can be done by hand will give us the answer 13.59, and as you can see, that is again very close to the actual answer that the calculator gives us. Let's now push this method further by taking a very large number like root 1050. Again, the nearest perfect square 1024 and 1089 have square roots 32 and 33 with difference 65. Again, we divide the distance between 32 and 33 by this number 65. So 1024 plus 26 will give us 1050. So traveling 26 parts ahead from the lower square root 32, between the distance between 32 and 33 should give us the root of 1050. Calculation is similar and the answer is 32.4, which is again a pretty good approximation. As you can see, even if the numbers get big, the method doesn't fail. But for bigger numbers, the by hand calculation will get a little longer, but you can still do it without the use of a calculator. So using this method, we have found the square roots of 8, 40, 185 and 1050, which were a mystery for us before. Usually we need to find the square roots in numerical problems in physics and chemistry. This method works for any non-perfect square and is extremely useful for exams where calculators aren't allowed. Using this method also helps you build a number sense, and if you practice enough, you'll also be able to do it just mentally. What I would like you to do next is take any number off the top of your head and find its square root by this method. Consider this a homework and tell me in the comments below what number you chose and what answer you got for its square root. If this explanation helped you, give the video a like, share it with a friend and subscribe for more clear and logical maths concepts. See you in the next video.